Author and blogger Simon Willison attempted to summarize the developments in the field of LLMs over the last few years.
Catching up on the weird world of LLMs.
Author and blogger Simon Willison gave a recent talk at North Bay Python, where they attempted to summarize the developments in the field of large language models, LLMs, over the last few years. They cover various aspects, such as what LLMs are, what they can be used for, how they're trained, and the challenges involved in using them ethically.
That's right. The author describes LLMs as large files containing binary blobs of numbers. They can be thought of as functions that can complete text and provide answers. They also mention that LLMs can generate text, like a poem about a sea otter getting brunch, although the quality may vary.
Exactly. The process behind LLMs is actually quite simple. They work by guessing the next word or token in a sentence. Mr. Willison compares it to the predictive text feature on an iPhone keyboard. However, he notes that while LLMs used in everyday applications like keyboards may not be a concern, there are larger models trained on terabytes of data that require significant compute power and may raise ethical concerns.
That's a good point. The scale of these models is quite remarkable. The author mentions that smaller models are used in applications like iPhone keyboards, while larger models like GPT-3 are trained on massive amounts of data and require substantial computational resources. It's fascinating how capabilities of these models emerge at certain sizes, but the exact reasons behind this are still unknown.
Absolutely. The author also takes us on a brief timeline of the development of LLMs. They mention that OpenAI, a major player in this field, was founded in 2015 and initially focused on reinforcement learning with Atari games. However, in 2017, Google Brain released a paper on the transformer architecture, which caught the attention of researchers at OpenAI, including Alec Radford. This architecture played a significant role in scaling the training of language models across multiple machines.
That's correct. OpenAI then released GPT-1 in 2018, followed by GPT-2 in 2019, and GPT-3 in 2020. GPT-3 was particularly noteworthy as it showcased the diverse capabilities of LLMs, such as answering questions, completing text, and summarizing information. The author personally experienced the power of GPT-3 when they gained access to it in 2021.
Absolutely. But what really stood out was an example from May 2022, where a new capability was discovered in an existing model that had been available for almost 2 years. This highlights the continuous potential for advancements and discoveries in the field of LLMs.
And the article concludes with a mention of ChatGPT, which was released in November 2022 and has brought even more excitement and possibilities to the world of LLMs. It's clear that this field is constantly evolving and expanding.
Definitely. This article gives us a glimpse into the weird and interesting world of LLMs, from their basic functioning as guessing next words or tokens to their ability to generate text and provide answers. The scale and capabilities of these models continue to be explored, and it's both fascinating and concerning at the same time.
Absolutely. It's important to consider the ethical implications of using LLMs and the challenges involved in leveraging their potential safely and effectively. The author raises valid concerns about ethics and prompt engineering, highlighting the need for responsible use.
That's right. And as LLMs continue to evolve, it's exciting to see models being trained in different languages and cultures, which can bring more inclusivity and diversity to the field.
Definitely. It's an ever-changing landscape, and we'll definitely be keeping an eye on the developments in the world of LLMs.
Absolutely. Stay tuned for more updates and discussions on this fascinating topic. In the previous segment, we talked about the different models and tools available for using large language models, LLMs, like GPT-3. Now let's dive deeper into understanding how these models work and how they can be beneficial in various scenarios.
That's right. One interesting finding from a paper called Large Language Models Are Zero-Shot Reasoners is that GPT-3 can solve logic puzzles, but it needs a little bit of guidance to get started. By explicitly instructing GPT-3 to begin its answer with "let's think step by step," it significantly improves its ability to answer these puzzles correctly.
It's incredible how such a simple trick can have such a profound impact on the capabilities of these models. And it's not just GPT-3, but advancements like this keep happening in the field of language models.
Absolutely. And if you're interested in trying out these models, here are some recommendations. ChatGPT is the cheapest and fastest option. GPT-4, developed by OpenAI, is considered the best in terms of capabilities. You can access it by paying OpenAI on a monthly basis or through Microsoft Bing for free. Claude 2 from Anthropic is currently free and offers a larger length limit of 100,000 tokens. It's equivalent to ChatGPT, but with additional capabilities.
That's a great overview of the available options. If you're looking to get started, how to use AI to do stuff. An opinionated guide by Ethan Malik provides excellent instructions and insights into using these models effectively.
Yes, and it's important to note that OpenAI is responsible for ChatGPT and GPT-4, while Claude 2 comes from Anthropic, a group that split off from OpenAI due to ethical concerns surrounding the training of these models.
One of the challenges with using LLMs is that they don't come with a traditional manual. Instead, there's a lot of information available online, often from people boasting about their achievements with low accuracy rates, which can be frustrating.
Absolutely. These models are also unintuitively difficult to use. While anyone can type in a question and get an answer, getting the best answers requires intuition and understanding the strengths and weaknesses of the model. Spending time and developing a deeper mental model of what these models excel at and where they might make mistakes is crucial.
Understanding how LLMs work is also beneficial. They excel at producing convincing text, whether it's true or not. It's important to be aware of this and not take their responses at face value.
That's a good point. Now let's talk about how we personally use language and learning models. For me, about 60% of my usage is for writing code. These models are surprisingly good at coding tasks because the grammar of programming languages like Python or JavaScript is much simpler than the complexity of the English language.
That's an interesting perspective. I no longer dread naming things thanks to LLMs. I can ask for ideas for names, and even if I don't use the exact suggestion, it often sparks creativity and leads me in the right direction.
Absolutely. LLMs are also great for finding synonyms and expanding vocabulary. You can ask them for a word that means something similar to what you have in mind, and they will consistently provide relevant suggestions.
One surprising use case I discovered is using LLMs for API design. While some criticize these models for always providing obvious answers, when it comes to API design, that's exactly what you want. A clear and straightforward solution.
That's true. These models can also be used for more complex tasks. In the article, the author shares an example of using GPT-4 to write code for measuring the size of files linked to hundreds of URLs without having to download them. The generated code was clear, well commented, and achieved the desired outcome.
The author estimates that using LLMs for coding tasks has resulted in a 4 times to 5 times increase in productivity. While it may not be the majority of their work time, it's still a significant improvement.
Definitely. Now, let's move on to a more exciting question. What can we build on top of these language and linguistic models? The REACT pattern described in a 2022 paper titled REACT Synergizing Reasoning and Acting in Language Models opens up new possibilities. It allows language and linguistic models to reason about a problem and suggest an action, which can then be executed in the real world.
That's fascinating. The implementation of this pattern involves giving LLMs access to tools and allowing them to interact with the outside world. It's like having an AI assistant that can perform tasks based on its reasoning.
Exactly. By leveraging the ability of LLMs to understand and generate English text, we can create functions that enable them to do a wide range of tasks. The potential applications are vast and can be both exciting and daunting.
Absolutely. Let's start by discussing the concept of retrieval augmented generation. This technique allows language models to answer questions based on information from their training data and available prior to their training cutoff date.
That's right. While these language models have a vast knowledge base, they're limited to the information they were trained on. However, there's a trick to make them answer questions about private notes and documentation.
Exactly. Instead of training a model specifically for this task, you can search the relevant documentation, extract the necessary information, and formulate a prompt that includes the question. This approach is surprisingly easy to implement and can be seen as a hello world of developing with LLMs.
But it's important to note that working well with LLMs requires additional effort and consideration. There are many pitfalls involved, and getting optimal results requires fine-tuning and experimentation.
Absolutely. The article also mentions the use of embeddings and vector search in relation to LLMs. These tools allow you to convert text into arrays of floating point numbers that represent the semantic meaning of that text. By comparing the similarity of these vectors, you can build powerful search engines.
That's correct. OpenAI provides an embeddings API that returns a 1,536-dimensional array for some text. You can think of this as coordinates in a high-dimensional space, where texts with similar meanings are closer to each other.
And these vector databases, which are optimized for nearest neighbor retrieval, can be used to build efficient search systems. OpenAI's embeddings API is one of the more affordable options available, but there are other alternatives that can be run on your own machine.
Moving on, the article highlights the challenge of populating the context effectively when using retrieval augmented generation. With limited token space, it's important to provide the best possible information for the model to answer user questions accurately. Best practices for this are still being developed, leaving room for innovation.
Definitely. The ability to provide language models with tools is another interesting concept touched upon in the article. ChatGPT plugins, which were announced in March 2023, allow you to implement a web API that performs a specific task. You can then train ChatGPT to use that API to answer user queries.
An example given in the article is the use of dataset, a web API for querying an SQLite database. By building a ChatGPT plugin, you can enable ChatGPT to answer questions about data hosted in dataset. This demonstrates the potential of combining language models with external tools to enhance their capabilities.
However, there are challenges associated with this approach. The article mentions a but where ChatGPT produced hallucinated results when dealing with long columns of data. These hallucinations occurred when the token limit was exceeded, leading to incorrect outputs.
That's a significant problem. It's essential to address these issues to ensure reliable and accurate outputs from language models. While there may not be a convincing solution at the moment, it's an area that requires further exploration and innovation.
Absolutely. Now let's talk about ChatGPT Code Interpreter, which is described as the most exciting example of what's possible when giving language models access to tools. This tool allows ChatGPT to write and execute Python code in a Jupyter notebook-style environment.
It's an impressive capability indeed. The article provides an example where ChatGPT was able to generate a fractal animation based on a user's instructions. The model executed Python code, handled errors, and iteratively refined the output until it achieved the desired result.
It's fascinating how the model can learn from its mistakes and iteratively improve its outputs. This approach serves as a workaround for the hallucination problem, as the model can identify errors and rewrite the code until it produces the desired outcome.
Absolutely. The ChatGPT Code Interpreter opens up a world of possibilities for creative coding and interactive programming. It offers a wide range of functionalities, including file uploads and downloads, making it a powerful tool for developers and AI enthusiasts alike.
Well said. And finally, let's touch upon the issue of transparency in the training process of language models. The article highlights the lack of transparency regarding what data is used to train these models. Understanding the training data is crucial for making informed decisions about their usage.
Indeed. It's important for organizations like OpenAI, Anthropic, and Google to be transparent about the training data to ensure ethical and responsible use of language models. The article emphasizes the need for transparency to make informed decisions about how to effectively utilize these models. Stay tuned for more updates and discussions on this rapidly evolving field. There's still much more to explore and learn.
For even more great AI dope, click on this next video here.